Hello everyone, and welcome to today's webinar. This is the 5th episode of our 12-part webinar series on countermeasure strategies for pedestrian safety. Today's presentation is going to focus on rectangular rapid flashing beacons. The presentation today will be delivered by Mike Sinecki. Mike works with Lee Engineering and worked in traffic engineering with the city of Phoenix for more than 25 years, during which time he was responsible for overseeing some of the first rapid flashing beacon installations in the city, as well as in the state of Arizona. We're really happy to have him here today to share his experience and expertise with you all. My name is Dan Jolene, and I will be facilitating the webinar today. Attendees, if you can hear me, please click the hand icon located in the upper right-hand corner of your screen to let me know that you can hear me. And I'll take a quick look around the room to see if I can see those hands going up, and I do. Very, very good. Excellent. I'm glad you all are here today to hear about rapid flashing beacons. It should be a great presentation. Before we get started, I just would like to share some background and administrative details with you about the webinar software. If for some reason your computer freezes up during the webinar, please reload the website, log back into the program, and you should be able to rejoin the session. We will be posting presentation slides and a recording of the webinar to the PBIC website, so you will be able to refer back to anything that you missed during the presentation today. The presentation slides are actually available now, and the archive of the video should be available within about 1 to 2 weeks. Please note that attendees will not be able to speak during the webinar, though you will have the ability to submit questions and comments using the chat function. You can feel free to ask a question at any time or send in your comments. We will be holding about 20 to 30 minutes for a discussion session after the presentation has concluded. Later today, you will be receiving a follow-up email from the UNC Highway Safety Research Center with a link that will allow you to generate a certificate of attendance for this webinar. Now, it's important if you're attending the webinar with multiple attendees at the same site, and you're the one who registered, you'll be receiving that email. So please remember to forward that email around to all the other folks who are in the room with you today so that they can also download their own certificate of attendance for the webinar. The email will also contain a link to the website where we've already posted the presentation materials from today's webinar. And then again, within 1 to 2 weeks, the page will also feature a copy of the video archive of the recording today. The webinar has been submitted to the American Planning Association and has been approved for 1.5 CEM credits. You can go online and check the AICP event calendar for more information about CEM credits if that applies to you. To learn more information about PBIC webinars, I'd encourage you to go to pedbikeinfo.org/webinars. You can check out some of the upcoming sessions we have or watch some of our video archives from previous webinars. Many of you have already seen the entire schedule for this particular webinar series, but I want to encourage everyone who's on the line today to consider signing up for some of these upcoming webinars. You can see here the next few topics we'll be covering on the slide. There are going to be a total of 12 webinars in the series covering a range of different countermeasures and design strategies. We're already, this is the 5th episode in, so we still have 7 webinars left. So there's plenty of opportunity to attend some of these sessions. And again, if you miss a session, you can always visit the website to view the archived recording. Now, before we start the feature presentation today, I'd just like to take a couple minutes to launch a quick poll of the audience. We were just interested in learning a little bit more about how many people are attending the webinar. So if you can just take a few seconds and cast your vote here. We're mainly interested in finding out if it's just you attending or if you have a small group of folks with you, and if so, is it just 2 to 3 people, 4 to 5, 6 to 7, maybe even more than 8? Take a few more seconds and vote in this poll, and then we'll be getting started with the session. Okay, very good. Just a couple more seconds, and then we will close the poll and move on with the presentation. Okay, very good. Thank you all very much for your feedback. We do appreciate that. With that out of the way, I would like to go ahead and kickstart the presentation today. So Mike Sinecki, you're up and should be ready to go. If you could just accept screen control whenever you see it, and open up your slides. Very good. I see your screen, and so please go ahead whenever you're ready.
Thank you, Dan. Again, my name is Mike Seinecke with Lee Engineering. I've got 35 years of experience in traffic operations and safety. 26 of it was with the City of Phoenix. While I was there, pedestrian safety was one of our biggest concerns, and we had very great difficulty at some of the mid-block crossings. We have wide, high-speed streets, and although people don't think of this as being a walking city, we do have a lot of pedestrians. But before I get into that, I want to give a couple of thank yous out to the people who are responsible for the device we're going to be talking today. Most notably, Michael Frederick, who's a transportation manager with the City of St. Petersburg, Florida, who first developed this in his city, or first installed it and had it evaluated. Some of the early research was done by Dr. Ron Van Houten of Western Michigan University. There is research that's been, I think it's just been wrapping up, Kay Fitzpatrick out of Texas A&M University, under ANDO with the Federal Highway Administration. And I understand there's NCHRP study research being done on this through Charlie Zaguer at the University of North Carolina. So some of the things I'll be talking today is going to be mostly of the early research. There's going to be a few things that I'm going to be talking about based on more current research, and there will probably be more things coming out in the not too distant future. Back in addition to some of my credentials, I am, in addition, working for the City of Phoenix for 26 years, and installing the first two, which I believe were in the state of Arizona, in the City of Phoenix. I'm also a former chair of the Transportation Research Board Committee on Pedestrians, and I've been a panel member for the FHWA research project that's been conducted by Kay Fitzpatrick at Texas A&M University. Task order number 4, evaluation of pedestrian safety countermeasures at urban and suburban mid-block crossings. In this particular presentation, I want to talk a little bit, start out talking about the history, talk about some of the early research, the interim approval that resulted from that early research, some of the official interpretations that have occurred based on more recent research and some other changes that have been found out, and go talk about some of the options and some guidance with respect to the rectangular rapid flash beacon, and then we're going to end up with another case study evaluation. First, going back, the issue started in the City of St. Petersburg. They had many multi-lane high-speed roadways presenting conflicts for pedestrians using the uncontrolled crossings, crossing mid-block or crossing at unsignalized intersections. Motorists yielding compliance rates were less than 2% overall at these crosswalks. And the city had over 100 uncontrolled crosswalks, marked crosswalks, and as of 2003, its pedestrian injury rate was 49.23 per 100,000 people, which was higher than both the country's and the state's pedestrian rates. The city requested permission to use a non-standard traffic control device by following the permission to experiment protocol described in section 1A.10 of the Manual on Uniform Traffic Control Devices. They actually, as a part of this, compared the pedestrian crossing compliance of the rectangular rapid flash dual, they had a vendor who said that they've got a new traffic control device that basically had rectangular as opposed to round flashers that they use at the crosswalk, under the crosswalk sign, that they said that would get a much higher compliance rate. And so the city agreed to let the vendor install the rectangular rapid flash beacons, and conducted studies at initially 2 crosswalks in March of 2006 and analyzed the results. The rectangular rapid flash beacons were alternative to traffic signals and hybrid beacons because the cost was only about $10,000 to $15,000 for the purchase and installation of these 2 units, which was significantly less expensive than other options. And using solar power to operate the LED beacons also reduced the operating cost and made it a lot less expensive to install. As I said, that the city requested the permission then from the Federal Highway Administration to experiment. The city experimented with 2 beacon rectangular rapid flash RRFB systems and 4 beacon rectangular rapid flash beacon systems at the same crosswalks for comparison, and also for comparison purposes. The 4 beacon systems allowed for the placement of beacons in the center of median, which gave motorists traveling on in the inside lanes of the multi-lane roadway a better view of the activated beacons. In all cases, there were yield markings 30 feet in advance of the crossings that were used in conjunction with the rectangular rapid flash beacons to alert motorists of the upcoming crosswalks and to encourage them to stop in advance of the crosswalk to reduce the chance of a screening crash, or what's called as a multiple threat crash. The initial success of the rectangular rapid flash beacons at 2 crosswalks led the city to install 17 more rectangular rapid flash beacons and to conduct a 2-year study of the 19 crosswalks, during which over 16,000 individual crossings were evaluated. As a result of the 2-year study, it was determined that rectangular rapid flash beacons led to sustained yielding over time. The baseline yielding percentage prior to the installation of the rectangular rapid flash beacons, as you can see in this chart, was about 2%. And then when they looked at it at various time frames over that, they were getting a sustained 80+% or more, even 730 days afterwards, 2 years afterwards. Also, the rectangular rapid flash beacons performed equally well at night. On one site at First Street, just south of 37th Avenue, had a yielding rate percentage of 99.4% at night when using the 4-beacon system. And the yielding compliance rate was dramatically higher than the baseline nighttime percentage rate at this location, which was 4.8%. And the increase in yielding percentage at night can probably attributed to the bright LEDs that are very visible at night. Go on, next one. Where they've been used, the rectangular rapid flash beacons have a lot more options for use than some of the other traffic control devices. They can be used at mid-blocks. They can be used at uncontrolled intersection approaches. There's nothing that says that they can't have one to be used for 2 crosswalks at an intersection, both the near side and far side, long as they're an uncontrolled location. And they may be used at roundabout approaches. And in fact, PROAG, which is considering the possibility of rapid flash beacon as equivalent accommodation for the multiple approach lanes at roundabouts. No decision has been made about that yet, but that's another possibility. And as well as trail crossings. These are the 2 reports that initially came out that evaluated the rectangular rapid flash beacons. There's the full report, and then there's a tech brief that came out in 2010. And the research that was in the tech brief, this represented some of the initial research on the rectangular rapid flash beacon. The study examined the effects of side-mounted yellow light emitting diodes, or LEDs, rapid flashing beacons at uncontrolled marked crosswalks in a series of experiments. Many methods have been examined to increase driver yielding behavior to pedestrians at multi-lane crosswalks at uncontrolled sites with relatively high average daily traffic. Only the treatments that employ a red phase have consistently produced high levels of yielding in previous studies. A series of 5 experiments examined the efficacy of rectangular rapid flash beacons to increase driver yielding behavior. These studies examined the effects of rectangular rapid flash beacons at 22 sites in 3 cities in the United States. They were St. Petersburg, Florida, Washington, D.C., and is it Mundelein, Illinois? I probably messed that up. Data were also collected over a 2-year follow-up period at 18 of these sites to determine the long-term effect of the rectangular rapid flash beacon treatments. Another objective of the study was to compare the rectangular rapid flash beacons with a traditional overhead yellow flashing beacon and a side-mounted traditional yellow flashing beacon. And the final objective of the study was to attempt to identify ways to further increase the effectiveness of the rectangular rapid flash beacon. This shows the 5 experiments that were conducted, and it came from the research report, Effects of Yellow Rectangular Rapid Flash Beacons on Yielding at Multi-Lane Uncontrolled Crosswalks. The first experiment compared the effects of installing rectangular rapid flash beacons on pedestrian signs on both sides of the crosswalk, 2 sets of beacons, to installing them on both sides of the crosswalk plus in the median island, so there would be 4 sets, or 2 per direction. The second experiment compared rectangular rapid flash beacons to traditional overhead flashing beacons, just the standard, the beacons that you'll see, and traditional beacons mounted beside the pedestrian sign, so sign at the side of the road. The third experiment examined long-term effects of rectangular rapid flash beacons at 18 sites in St. Petersburg, Florida, and short-term effects of rectangular rapid flash beacons at 3 sites in 2 other parts of the country. And the fourth experiment examined the efficacy of direct aim technology that allowed rectangular rapid flash beacons to have maximum brightness at a particular point in the roadway. And finally, the fifth experiment examined the effect of placing additional RRFBs on the crosswalk advance warning signs. As a result, MUTCD issued an interim approval, and from the memo, this basically talks about the research results that were in it, and it tells you why it was installed. The research results led to the issuance of their interim approval. The results were very high motorist yielding rates, mostly high in the 80%, and compared to 15 to 20% yield rates for standard yellow flashing beacons where they're at the side of the road or overhead. And the high rates of yielding for motorist yielding were sustained after 2 years of operation. And also they found no negative effects associated with the rectangular rapid flash beacons. Again, from the MUTCD interim approval memo, the rectangular rapid flash beacons had very high compliance rates, are previously unheard of for any device other than a full traffic signal or a pedestrian hybrid beacon. At the time, the pedestrian hybrid beacon was not, and was referred to as the Hawk at the time, was not even in the manual on uniform traffic control devices. And the St. Petersburg data also shows that the driver exhibited yielding behavior much further in advance of the crosswalk with an RRFB compared to a standard yellow flashing beacon. The data from other locations from other than St. Petersburg was limited, but also showed results similar to St. Petersburg. Data from one site in the District of Columbia showed the driver yielding rates increased from 26% before it was installed to 74% 30 days after operation, and the DC yielding distances also increased comparable to the St. Petersburg results. And a study of 2 rectangular rapid flash locations in Miami-Dade County, Florida, as reported in a TRB paper, they found that the following effects were significantly reduced to negligible levels: evasive conflicts between drivers and pedestrians, and the percentage of pedestrians trapped in the center of an undivided roadway because of non-yielding drivers in the second half of the roadway. So as mentioned earlier, the interim approval was issued July 16, 2008. It was the interim approval 1A-11. It was issued prior to the publication of the 2009 Manual on Uniform Traffic Control Devices, but due to the rulemaking requirements, the results were not completed in time to get it into what would be the 2009 manual. And this device is expected to be included into the next manual, and of course the date of that manual is not known, whether it's going to be 2016 or 2017. In addition to the interim approval, you go onto the FHWA website and you just put FHWA interim approval. You could look, you can get the actual memo for the interim approval. There's access to the St. Petersburg experimental final report, and there's also a number of official interpretations that have occurred. And I believe there's 9 there now, and I was told that one additional one is going to be issued any day now. That we'll be talking about later, about the placement of the lights above versus below. That has still not been issued, and I'm looking for that daily. Of course, if you're going to be using something that's under an interim approval, the request, an agency has to submit a letter of request on agency letterhead addressed to the Director of the Office of Transportation Operations. And although it's not required by the Federal Highway Administration, it is a good practice to keep all the district division offices notified. And the FHWA requests that agencies ask for jurisdiction-wide approval or blanket requests, and even when agencies do not request jurisdiction-wide approval, the FHWA typically grants jurisdiction-wide approval so that agencies don't have to request approval for any additional installations. And of course, if your state has requested it, and then you don't have to go through the exercise of making the request. Agencies who request approval to use a device allowed under an interim approval, such as a rectangular rapid flash beacon, must agree to the following. You have to agree to the restore of the site, the interim approval, to a condition that complies with provisions in the manual on uniform traffic control devices with 3 months following the issuance of the final rule of this device. You must agree to terminate the use of the device or application at any time it is determined that a significant safety concern is directly or indirectly attributable to the device or application. And the FHWA's Office of Transportation Operations has a right to terminate the interim approval at any time it deems there is a safety concern. If an agency opts to use a rectangular rapid flash beacon under this interim approval, following design and operational requirements shall apply and shall take precedence over any conflicting provisions of the manual on uniform traffic control devices. And first of all, the RRFB shall consist. And I'm hearing some feedback on the phone. I can assure you it's not coming from my office, so I'm not sure where that's coming from at all. Okay, it went away. An RRFB shall consist of 2 rapidly and alternatively flash rectangular yellow indications having an LED array based pulsing light sources, and shall be designed, located, and operated in accordance with the detailed requirements specified in the interim approval. They should only be installed, or they shall only be installed as a warning beacon, so they're not as a regulatory beacon. They should only be used to supplement a W11-2 as if it's a pedestrian crossing sign. Initially, it was only a W11-2, the PED warning sign, and the S1-1, which is the school warning sign, along with a downward diagonal pointing plaque located at or immediately adjacent to a marked crosswalk. One of the official interpretations also added the W11-15 trail crossing sign. These are not to be used at crosswalks controlled by yield signs, stop signs, or traffic signals. And they may be used at a crosswalk across the approach to an egress or a roundabout controlled by yield signs. So that's the only exception where they can be used at a yield sign. If sight distance approaching the crosswalk is less than desirable and less than deemed necessary, an additional advanced rectangular rapid flash beacon may be installed in advance of the crosswalk to supplement the advanced PED warning sign, the W11-2, the trail crossing sign, or the school crossing sign with an ahead W16-9P plaque. And the additional, the advanced rectangular rapid flash beacons shall be a supplement and not a replacement to the ones at the crosswalk. So you can't just install advanced ones. You have to have them in conjunction, and they have to be operated as a all at once. They cannot be operated independently. For any approach where the rectangular rapid flash beacons are used, 2 W11-2 or W11-15 or S1-1, that's the PED warning sign, the trail crossing, or the school crossing warning signs, each with a rectangular rapid flash beacon and a W16-7P, which is the downward arrow, downward diagonally pointing arrow, shall be installed at the crosswalk, one on the right side of the roadway and one on the left side of the roadway. If you have a divided highway, the left side one should be installed in the median, if practical, rather than on the far left side of the roadway. And as I said earlier, the advanced, the rectangular rapid flash beacons, the beacon site, the flashers themselves, shall not be installed independent of the crossing signs for the approach. They have to be installed on the same support for either the PET, the trail, or the school warning sign with the downward arrow plaque. Let's get on to the next slide. Each rectangular rapid flash beacon shall consist of 2 rectangular shaped yellow indications, each with an LED array based light source. Each rectangular rapid flash beacon shall be a minimum of approximately 5 inches wide by 2 inches high. And the 2 rectangular rapid flash beacon indications shall be aligned horizontally, with the longer dimension horizontal and the minimum space between the 2 indications approximately 7 inches, measured from the inside edge of one indication to the inside edge of the other indication. Some of the other conditions of approval is the Outside edges of the rectangular rapid flash indications, including any housing, shall not project beyond the outside edges of the signs that are listed there. Subsequent, either the ped warning sign, the school warning sign, or the trail crossing sign. As a specific exception to the 2003 manual and the 2009 manual, the rectangular rapid flash beacon shall be located between the bottom of the crossing warning sign and the top of the supplemental downward diagonal pointing arrow plaque, or in the case of a supplemental sign or advanced sign, the supplemental ahead plaque, rather than 12 inches below or above the assembly. Now, as I said earlier, the Federal Highway Administration will be very shortly issuing an interpretation to allow the rectangular rapid flashers to be located above the signs in addition, as an additional alternate position. The ruling should be coming any time. I was told that it possibly might come before my presentation today, but it still hasn't been come out as of the last time I checked this morning. But I expect it to come out sometime in November. But until that comes out, it's a shall condition to be using it. Some other key, the flash pattern is when activated, the two yellow indications in each rectangular rapid flash beacon shall flash in a rapidly alternating wig-wag flashing sequence, the left on and then the right on. Each of the two yellow indications of a rectangular rapid flash beacon shall have 70 to 80 periods of flashings per minute and shall have alternating but approximately equal periods of rapid pulse light emissions and dark operation. During each of its 70 to 80 flashing periods per minute, one of the yellow indications shall emit 2 rapid pulses of light and the other shall emit 5 rapid pulses of light. Now initially, the original said 2 rapid ones followed by 3. When they found that when the human eye only sees 3 on the right side, however, when they put an oscilloscope on it, they found out that there was actually 5 rapid flashes. So an official interpretation came out to make changing it from a 2-3 to a 2-5. Also, last year, July of 2014, a second flashing pattern was approved that's called the WW plus S flashing pattern, or the wig-wag plus simultaneous flash was allowed. And you're allowed to either use the current flash pattern or to use the WW plus S flash pattern. And this is based on a flash cycle length of 800 milliseconds, and the official interpretation has it in. It has all the details of the actual new flash pattern. The advantage of the new flash pattern, during testing, it found out that it had as good, or if not better, driver recognition or driver attention. And in fact, it actually had more dark spaces in between the flashes. And it's because it had more off time or more dark time, there was less energy usage associated with it. So there are some advantages from that perspective. The flash rate of each individual yellow indication shall be designed to avoid frequencies that might cause epileptic seizures in individuals. The light intensity of the yellow indication shall meet the minimum specifications of the Society of Automotive Engineers Standard J595, which for directional flashing optical warning devices for authorized emergency, maintenance, and service vehicles, dated January 2005. Now, in January 9, 2012, an FHWA interpretation also stated, it's our official interpretation that the yellow lights used as warning beacons in RRFBs shall meet the SAE J595 requirements for peak luminous intensities for a Class 1, because there's different classes in it. And so the Federal Highway Administration specified it has to be Class 1. Now, the way they operate, normally they're dark when not activated, and they shall initiate operation only upon pedestrian actuation or pedestrian detection. So they cannot be continuously operated, and they cannot be time of day operated. It has to have a pedestrian actuation either by pushing a button or by having some kind of an activation by standing in a certain place or crossing a certain place. They shall cease operation at a predetermined time after the pedestrian actuation or with passive detection after the pedestrian clears the crosswalk. So you can make it so that's preset time. And you can use the MUTCD clearance at 3.5 feet per second, or you can use it 3 feet per second, plus an initial startup time is to get you a time of how long that term shall be. There's no requirement in the manual. It has to be a given set time. And all the rectangular rapid flash beacons associated with a given crosswalk, including the advanced ones, if used, shall, when activated, simultaneously commence operation of their alternatively rapid flashing indications. And they should all cease flashing simultaneously as well. If a push button is used, you require to you should use the push button to turn on warning lights, as seen in the picture on this slide, adjacent to the push button itself. Some of the actuation options, as I said earlier, it could be push button, as you see on the left, or it could be passive operation. Tell you a little story about that picture on the right. That is a location where they actually, what's circled in blue are 2 bollards. Now, I'm hearing a lot of noise in the background, and Dan, are you hearing this too?
I am hearing it. If we can, everyone should be muted, but if you're not muted, if you happen to be on a panelist line, if you can please mute your phone. We're getting a lot of feedback noise through the...
Muted.
Okay, I'm now unmuted. Very good. As I said, it could be push button activated or passive detection. The picture on the right, those 2 circle things as a bollards, and this is at a University of Texas at Arlington Crossing. If you look in that white line was supposed to be, this is separating a parking area from the campus itself, the main campus. And it used to have a push button operation, and they were having difficulties getting it to work because people just weren't pushing the button. So they went to the bollard system that it was like a sealed beam that you cross the bollard and it automatically would turn on the rectangular rapid flash beacon for a certain time. They learned very quickly that the people were not crossing in what they designated as that crosswalk and had to move the bollards further apart. And now it's working very well, and the people on the campus, the university campus, said that it's working. They're very pleased with the operation. However, they have another one about a half mile away on campus that's still push button operated, which they're saying is getting very little use. In addition, there should be some kind of accessible pedestrian signal features, such as you can use a locator tone. It's not a requirement, but to let people know that it's there. But the message that's given to the pedestrian should only indicate that a beacon is flashing, not when pedestrians are crossed, because this is not a regulatory traffic control device. It's only a warning period, a warning flasher to driver. If an audible message is used, it should repeat twice at the beginning of the flashing period and should be a speech message that says, yellow lights are flashing. Get on to the next slide. And then some additional design considerations. First of all, a rectangular rapid flash beacon is not a substitute for good crosswalk placement. If you don't put it in the right place, it's not going to be used appropriately. And you'll have to also remember that the crosswalk is still the primary traffic control element that assigns right-of-way to the pedestrians, not the flasher. The flasher only supplements the sign to gain attention to the sign itself, and the sign is a warning device, but it's the crosswalk that says that you must stop for the pedestrians. Or yield, if your state is a yield state. Yield means yield, and most of the state rule laws either say stop for pedestrians or yield and stop if required. And so the prerequisites for best use is to best practice is to the appropriate make sure you have the crosswalk in the right location, have the pavement markings associated with it, and for nighttime use, have lighting associated with it. Some people ask, what are the speeds and the conditions on when when this device should be used, when the rectangular rapid flash beacon ceases to become effective. St. Petersburg has, which has been the initial location that started exploring the use of them, has started an envelope on this, and this is the results that actually came out in, I believe, in 2010, where they've been installing them on some wider, higher volume, and higher speed streets. And I just want to add a caution to you that when you get to higher speeds and higher volumes, and I don't know of any given threshold, but when you get to higher speeds and higher volumes, the rectangular rapid flash beacon becomes less effective. And especially if you don't have it placed in the median. But this slide here shows that they performed well in these applications in St. Petersburg, with still giving 75% yield rates with no crash problems under the applications shown on this slide. And of course, all the other rules for crosswalks apply, making sure that the crosswalk is visible, having good sight distance at advanced stop or yield lines. This case here, they put advanced school pavement stencils. This is an example of our very first one that was installed in Northeast Phoenix that was actually replaced an in-pavement flashing crosswalk, which didn't work too well and didn't last more than 5 years. This was replaced at just a fraction of the cost of the device. And we did everything to make it more visible. And another thing we learned too is if you have a tree nearby and if you're using solar power, make sure the tree branches are trimmed back and kept trimmed back. As I said earlier, the timing should be the duration for the crossing plus a startup time. And you can look up at the MUTCD, they use 3.5 feet per second or 3 feet per second, depending on the pedestrians that you have there. And the nice thing about the rectangular rapid flash beacon is that right after it goes through a flash cycle, you can have it set up to flash immediately afterwards. There's no gap time in between that needs to be done. You don't need to have a dark time in between because it is a warning device. So right after one interval, you can have the next flashing interval. The other option that you can use and some of the devices have as a flasher on the side that is directed and visible to the pedestrians in the crosswalk, so to let them know that the flasher has been activated. And you can see here, this is again the 40th Street and Danbury one near a high school. It shows the people as they're crossing that the flasher in the side of the device indicates that the flasher is operating. Other places that have been used, the original manufacturer had only said his device was intended for side of the road and median application. He was a little concerned about the directionality or the visibility if used overhead. However, other traffic signals that use LED arrays are used overhead. Most traffic signals now are LEDs. The city of Phoenix, just after I left, have used a number of applications overhead. Their concern right now is that the overhead flashing beacon does not stand out that well during daytime use, and I think they're going to be exploring, or they should be exploring, possibly a larger flasher for the overhead application, only because it just does not stand out as well when you're putting up higher. You'll notice even as a sign, the higher you place it, the more and more it looks like a postage stamp. There has not been a formal evaluation of overhead uses of rectangular rapid flash beacons, and there may be some adjustments to look at in terms of pointing it more at the drivers in a certain approach area to make it more effective. As I said earlier, whenever you have a median, putting it at the median, the flasher at the median, getting it closer to drivers so that it's more in the line of sight, more in the cone of vision. So that's a preferred, and in some cases, if I go back to the last slide, the city of Phoenix is trying to install on all of the arterial streets. This is probably the widest street that I've seen it installed on, 3 lanes in each direction. It's not a very pedestrian-friendly street to start out with. This street, they did put a median in there, try to make it a 2-stage crossing, and put the rectangular rapid flash beacons. And I was told that the rectangular rapid flash beacon is now going to be a standard application to the 2-stage crossings in arterial streets. But by putting it in the median, it's more within the cone of vision for the driver. As I said earlier about some of the research for the median rectangular rapid flash beacon, the standard yellow overhead beacons, just the standard either the alternating or simultaneous flash, had changed compliance from about 11 to 16%. This is driver yielding compliance. The side-mounted rectangular rapid flash beacons, just on the sides and nothing on the left-hand side, just on the side of the road, brought the yielding under the same circumstances up to 78%. and then adding it into the median island increased it to 88%. So you got really good yielding rates at that time. Also, the standard yellow side-mounted beacons increased yielding compliance only from 0 to about 16%, where the side-mounted rectangular rapid flash beacons increased yielding just using it on the side alone. In another experiment, just to 72%. So it was a much different yielding rate. Also, it should be known that anytime you put something in new, it should be accompanied by education and enforcement, especially if you haven't used these in your jurisdiction before. Yielding compliance should be monitored by the police, and if they're not getting good compliance, have the police go out there and do friendly reminders to drivers. Sometimes monetary amounts associated with those friendly reminders can be very helpful to increase it until you get to about 75% yielding rates. And if you have some other problems or complaints, do additional enforcement if the yielding rate drops. Some cost information on these devices. This is based on a report that was done in October of 2013 by the University of North Carolina. It's called, the report is Costs for Pedestrian and Bicyclist Infrastructure, resource for researchers, engineers, and planners, and the general public. This is available on the web. And in this particular case, for the rectangular rapid flash beacons, they had got costs for 4 installations from 3 different jurisdictions, and they had an average cost of about $22,250. Our initial installation that had they had the flashers on the side and in the median cost $27,000, not including the cost of the median, which was already there. The nice thing about these is that cost can be low if you do it solar powered. They're radio controlled, so there's not a need to have conduit in if you do it solar powered. And if you have the availability for good solar sunlight at the location for a longer period of time, LEDs are very low power use. There is a concern about the battery length and usage, and having to at times monitor the battery and making sure that these devices are still working. But the costs have gone down quite a bit. I know that the costs there's a lot of different things that can affect the costs, including if you're going to have it hooked up to actual power and the conduit that's associated with that. Overhead feed is going to be a lot cheaper. If you're going to put it on the tubular poles versus putting it on something like a 10-foot or 8-foot signal pole to make it last longer and have it more stability associated with it. So there are different things can affect the cost of these devices. Now we're going to go through a case study. A case study from an early installation that on PINELLAS Trail. This is a multi-use trail crossing. It was a really busy trail for pedestrians and bicyclists. As you can see in the top picture, it shows the motorist approach. The bottom picture shows actually the trail approach. It was an urban 4-lane arterial with 15,000 vehicles a day. The trail use was pretty high, 1,300 to 2,000 trail users per day. 80% of the trail users were bicyclists, and the yield rate overall in the baseline time was less than 2%. So less than 2% of the motorists were yielding to people crossing at this location. And they noticed something too in the before studies, that 18% of the trail users had to wait in the center of the street, and you can see right now that there is a painted center area in there for traffic to clear in the other direction. So it was, and if you've ever been in a street like that, with whether you're just standing in a painted median area, it's not very comforting to do that. The part of the solution to this location included installing a raised median, as well as rectangular rapid flash beacons on each side of the road and in the median, which was done in 2008. It was done with push-button activation, and of course it was all radio controlled from one of the locations to the other location. As a part of the research that they looked at, they were also looking at the push-button activation. They were not getting 100% push-button activation. In this particular study, you can see with the stop sign, they had a sign that says push-button to activate beacons. The before motorist yielding was recorded at 2.9%. That's despite the fact that in the report it said the baseline yielding was 2%, but it is the same vicinity. After they put in the beacon system and the median, they looked at the actuation amongst the users. They found out that the pedestrians were far more likely to use the flashers than the bicyclists. Some bicyclists, if they saw the gap, they would just ride on through. But when it was not activated, they still got a higher, with the raised median island, they got a higher yielding percent. But when the rectangular rapid flash beacons were activated, they got almost 80% yielding from the drivers. Pretty darn good. The other thing is that looking at the trail users that used to be stranded in the painted median or in the center of the street, before it was 17.8% or close to 18%. Afterwards, after they put the rectangular rapid flash beacon in, it was actually went down to about 6.3%. So it was much better driver compliance and driver yielding than before. And this lists some of the interim reports and some of the studies that have been done, the interim approvals, the before and after study of effectiveness of rectangular rapid flash beacons used with school signs in Garland, Texas, and the driver yielding results for 3 rectangular rapid flash beacon patterns. As I said earlier, a second pattern has now been approved. When they did the study on different patterns, there was 2 different patterns that were that performed as well and as the current one, if not better. And the Federal Highway Administration, in an attempt for uniformity and standardization, they decided to allow one of the additional flash patterns as an optional flash pattern to use. And probably because of the lower power usage and the higher, the little bit better driver reaction, that may eventually morph into being the optimal or recommended flash pattern. With that, I believe that's all I have with the slides themselves. Dan, do we want to open it up for questions and unmute yourself?
Hey, thanks, Mike. I appreciate that. And everyone on the line, I'm sorry for the feedback we're getting. I'm not totally sure where that's coming from. We're going okay for now, though. So I just asked everybody to make sure your lines are muted and we can get through this question and answer session, hopefully without too much distraction. Mike, you covered quite a bit of information in your presentation, all very valuable. Thank you for that. I want to see if you're okay with it, what I might suggest we do is leave the current slide that you have on your screen up during the Q&A portion, because I think folks may want to copy some of these links down. We can keep these up. Again, you will be able to access the slides, but just while we're talking, I think this will be helpful for people to view. We got a lot of good questions, Mike. We're getting quite a few about from folks asking questions about comparing the rectangular rapid flashing beacon to the perimeter lit pedestrian signs that feature the line of small lights around the perimeter of the sign that kind of do a continuous flash 24 hours a day. There are some clear differences, but Mike, I wonder if you might just outline a few of them and talk about maybe benefits or setbacks based on the kind of signage you use.
Well, anything that flashes 24 hours a day afterwards becomes a part of the landscape and really it loses a lot of its effectiveness. And I think that's one of the reasons why the flashing beacons were pedestrian actuated or pedestrian detection, or it could be bicyclist actuated. I know that as part of the research that was being done at the Texas A&M University on it, they did look at the sign that had the LED flashers around the borders. And one of the issues with the flashers, especially at night around the borders, was being able to see what the sign said. Because one of the things that they looked at is, can you identify what sign was there? And the flashers many times will flash out the sign. So that's been one of the concerns about using that. And I've seen some applications that have them around it. Most applications don't, because it's less expensive when you don't have around it. I've seen also the flashers around the sign and other applications in daytime use, and I don't know if it's people like here in Arizona, but we have 70% cloudless days, and the flashers around the borders of the sign, the perimeter of the sign, in the daytime just don't pack a punch. At nighttime, they could be so bright you can't see the message on the sign. You don't know what the warning sign is. and I've seen some in person in I think it's Frankfort, Kentucky, where during the daytime I was again did not the flasher did not stand out that well. But some of the research results are showing that the nighttime it'll flash out the message on the sign.
Okay. Mike, a couple of notes on your slide toward the end on cost information. A couple of questions about whether those costs include the full assembly, or is that a cost per mount, and does that include what does that assume in terms of whether these are wireless units or whether they're hardwired?
I went and checked the report. Those were the cost of the entire installation at the intersection. So if it depends on how you install them, I found out that even though the prices have gone down, the people in Phoenix are now putting them on more bigger poles, on A poles, for longer life on it, and of course the foundations are bigger, and so the costs are going up associated with that. But the costs that were shown in the report are costs for the entire installation. As I said, our very first ones were cost $27,000 for 2 rectangular flash beacons in per direction. The only thing we did was put in the base. It was just a base that was put in that was about 2 foot long. They actually came and assembled it and put it up for us. So it was the installation and the equipment cost for that. If you're going to something overhead, I know that the standard cost for an overhead mast arm, it is typically a mast arm pole. Just that alone is going to add $6,000 to it. And if you're going to put conduit in to it for wire for power use, that can add some cost to it. So there's different ways you can change the costs. If you have overhead wire power to it, then it's going to bring the cost. It's not going to be as much. It's going to be less cost. So there's a lot of variations to it.
Okay. Okay. We got a good weigh-in here from Michael Frederick in St. Pete. How's this for specific? Mike told us that the current cost in St. Pete for 2 units installed is $9,812.50, and plus the concrete base. So
Okay.
there's an exact number from someone who's done a lot of these. So that's one quote for you.
That's excellent. I think no one knows more about that than Michael Frederick. He's probably the most experienced on the use and application of it.
Yeah, Mike just told us he's got 104 installed down there today. So
wow.
If you're looking for a good resource, a reference person, I think we've certainly found the city where you need to be looking to get that information in St. Petersburg. And Mike, if you're willing to for us to distribute your information, just chat that to me, and I'll repeat it for everybody. Let me move on though, and get to some other treatment comparisons. We've got a lot of questions. Obviously, I just asked the question about the perimeter lit sign. A lot of questions, obviously, and we knew we were going to get these on comparing the rapid flashing beacon to the pedestrian hybrid beacon. And I don't want to dwell, for too long on the PHB because, as many of you saw, we are covering the pedestrian hybrid beacon next week in next Thursday's webinar. So you may want to check that one out for a lot more detail. But Mike, can you just speak generally about some of the differences and where you may use one compared to the other?
Yeah, the pedestrian hybrid beacon, which was originally developed as a hawk, but it was adopted in the 2009 manual as a pedestrian hybrid beacon, is a regulatory traffic control device. It has red lights that come on. There are some applications where the streets are too wide, the traffic is too fast or too busy, that you may want to go to a pedestrian hybrid beacon over a rectangular rapid flash beacon. But the main difference is one is warning versus one is regulatory. And I think that obviously if you're going to do a pedestrian hybrid beacon over a wide street, you're going to have mast arms, or you're going to make it effective. You're going to have something that is put in front of the driver, but so it's regulatory versus a warning sign.
Okay. Keeping on the same topic, or the same general sort of comparing the rapid flashing beacon to other treatments. We got quite a few other questions about comparing the rapid flashing beacons with in-street lights that are embedded into the crosswalks. Mike, I don't know how much experience you have with these kinds of lights, but can you compare the two together? I mean, obviously they're both kind of using that push-button activation to activate a lighting system, but talk about maybe comparisons between the two. or why you'd want to pick one rather than the other.
The two main differences is that you're putting something in the ground, it's more expensive to do so because then you have to do the conduit, you have to have the lights in the pavement. And then we had one that lasted 5 years. We actually invested $40,000 into it, and the equipment that was originally installed wasn't supported by the vendor. So the other thing too is if you have lights above the pavement and closer to the driver eye height, is going to be, to me, more effective than something in the pavement itself. And if those places that have snow and rain can also make an in-pavement system less effective. We only installed one, and then that was replaced with a rectangular rapid flash. We only installed one in-pavement crosswalk, and after 5 years, that was replaced with a rectangular rapid flash beacon. We've gotten much better response out of it too. But the other thing I want to say about equipment, if you have a vendor that wants to sell you one, typically they're given with 2-year warranties, but have the people who are going to maintain it after you receive it, have them, if it's going to be your signal crews or someone else, have them look at the equipment and make sure that they're satisfied that the equipment is well made and it is maintainable, and it doesn't look like it's been made in someone's garage. And that's one of the things that we do, is we have our signal maintenance people inspect the equipment before we use a new device or a new manufacturer, to make sure that it's something that they're going to be able to maintain and live with after the warranty is gone.
Okay, all right, very good. You're talking a little bit about some considerations for maintenance concerns with the latter in-street crosswalks that we mentioned, but talking about the rapid flashing beacon itself, can you speak to any sort of maintenance or lifespan questions? People wondering if, yeah, they may not be as high of a cost to go out and install, but what are they looking at in terms of routine maintenance? And another sub-question to that was, is it possible to go out and replace the signage without actually having to replace the flashers and the mount? Any thoughts on any of those questions?
And I don't know. It depends upon the manufacturer of the device, whether it has a separate sign. I know the first units we bought were all one-piece sign and the flashers themselves. We've had pretty good luck in terms of maintenance, but it's also important that you'll have the vendor, whatever you get it from, does stand behind the product and can replace the things that are going out. I just spoke to my colleagues earlier today, and they said that the biggest concern they've had was maintenance-wise is knockdowns. So that every once in a while someone's going to drive off the street. That happens with signs, that happens with signal poles, and it'll happen with these devices. And it's good to have a couple of spares so that when they go out, that you can rapidly put them back in action again. So other than that, some components may go out, and just make sure that you have a vendor who is going to be able to respond quickly, or better than that, have the spare pieces of equipment in your signal shop or in your inventory so that they can be replaced. We have not had a lot of maintenance problems associated with them, and for across the country, I have not heard of a lot.
Okay. All right. I'm gonna go back maybe to sort of the beginning of your presentation, Mike, and you talked a little bit about what we do know about the safety effects of the rapid flashing beacons, and then maybe what we don't yet know about what they're able to do. Can you just summarize again the current, as of today, the current state of literature on has been proven with respect to pedestrian rapid flashing beacons, and what is still officially not yet known?
Well, I think that I know the research showed that that at least in the laboratory tests, that the flasher positioned above, sorry, I should say closed course tests, flasher positioned above may have a little less distracting effect for nighttime use, or to be able to see the pedestrian. The most important thing is the flasher is not going to be so bright that it detracts away from the pedestrian that's crossing, because the most important thing is to be able to see the pedestrian. And along that issue is brightness, and brightness has been looked at by TTI, or Texas A&M University, and there is such a thing as too bright, and there also is such a thing as not bright enough. So when they looked at some of the products on the market, some of them weren't bright enough, And then they were able to adjust the brightness levels, and they found out that through the research that there is probably a sweet spot where an ideal brightness level would be. More research is needed on the overhead application and to make that more effective if it's going to be used on wider roads, like the example I showed in one of the slide presentation. When you get to 3 lanes in one direction, that's when you're probably going to want to use an overhead application, and that's something that has not been researched that well. But I think the flash patterns have been researched, and I think that that's something that's a new flash pattern has been accepted. But I said that earlier that 2 flash patterns came out equally well, and they selected one that had less power usage, more dark in between the bright that makes the flasher more visible to drivers, yet has less energy draw on your battery or solar panel.
Okay. All right.
And as far as getting back to maintenance, there should be, just like you have traffic signals on a maintenance schedule, and many agencies even have certain signs on a maintenance schedule. There should be some periodic check, whether it's annual or less, to make sure the device is working, to make sure that the battery, if you have it on solar power, is working, and that there was a case that was a solar power device. It was not a rectangular rapid flash beacon. I would go to early in the morning, look at it, it was not. I'd call our signal crews, they'd go out there, and they say it's working fine. And then I'd go out there the next morning. It was supposed to start at, I think it was 6 or 7 in the morning. It wasn't on, and they'd go out there. It turns out that the battery was not holding the charge. By the time that the signal crews got out there, the battery the solar panel had enough power coming to operate the flasher. It was not a flasher, it was actually a driver's feedback sign. And so that there should be a periodic inspection on the adequacy of the battery to make sure that it's effective.
Okay. Mike, this is a bit of a preview to another webinar you're going to be doing with us in the same series on pedestrian lighting strategies. Can you say anything about some of what the studies have shown, or maybe your experience of positioning pedestrian lighting at these crosswalks in conjunction with rapid flashing beacons? Is there placement or strategies that work particularly well when you're having both at one location? So thinking about if you have a rapid flashing beacon, where do you put your lights, things like that?
Yeah, the latest studies show that if you put the light in advance of the crosswalk on each approach, it's going to light the front of the pedestrian. If you put the light exactly overhead or behind it, it's going to be more silhouette. And the drivers will recognize a pedestrian or a bicyclist crossing if it's front lit, so you can actually see the person as opposed to seeing a silhouette of an individual crossing. And that we'll be talking about that one, I think, in early December on the lighting for pedestrians.
So we will be covering, just as Mike said, an entire webinar on lighting strategies and all that. And Mike will be back for that session, so check that one out if you're interested. A few questions about spacing a rapid flashing beacon system with respect to sort of proximity to a signalized intersection. Mike, do you have any rules of thumb for where or a distance within which you wouldn't want to place a rapid flashing beacon system at near an intersection or a signalized intersection, or does it really not matter? It's kind of case specific.
It's going to be somewhat case specific because depending on the width of the roadway, and you really don't want to have it within the place where the vehicles are queuing from the nearby signal. But in some cases, it may be best to have, if you're going to be, if the pedestrians are not going to be crossing at the traffic signal, and there are some cases where we've gone out and seen where the pedestrians you just can't get them to cross at the signal, it's better to put the crossing treatment at where they are most likely going to be crossing. And it may mean a block away, or it may mean sometimes a half a block away, but it's really going to be case specific, because you wouldn't do that on a major arterial road that may have barrier traffic and the vehicles may be queuing back through that crossing. So in some cases you may have to force the issue by either fencing in the median or fencing along the sides to get them to your preferred crossing point. But there'll be other applications that it might be best to say a block away from a traffic signal to have a rectangular rapid flash beacon. I think that certainly no closer than 300 feet, but I don't have a specific number.
Okay. Okay. you mentioned some information about pedestrian actuation and the push buttons that are placed with these systems. And obviously, they are activated by the pedestrian at roadside. But you talked about the push buttons, and you also talked about some of the passive technology. Can you elaborate on what sort of technologies are used in the passive detection for these systems? Is that infrared? Is it, or can you say just a bit more about that?
Yeah, I know I've actually done some experimenting with microwave to do that, and I don't know what the bollard system uses, but it's similar to what's used many times the bollards at grocery stores that open the door. But in some cases, we use people who are not pushing the buttons, or not getting to push the buttons, and that many times it's I've noticed at traffic signals where we've actually had to take push buttons out because pedestrians, the more pedestrians that were there, the less it seemed like that they seemed to want to think that they needed to push the button, that they expected to have some kind of automated detection. So we go to a fixed time for traffic signals. Now for these devices where you can't go for a fixed time, having some kind of an automated detection, whether it be microwave or video. I know that in the city of Tucson that they used microwave for a while for when they were doing the time extensions at some of their pedestrian hybrid beacons, and they've changed that to video detection. If you're going to use video detection, you have to have some kind of a lighting source so that person can be recognized on camera.
Speaking about that as well, and you didn't cover this, and I apologize if you don't have much information about this, Mike, but I figured I'd ask it. You hear a lot about at signalized intersections accessible pedestrian signals, or giving audible cues to individuals with disabilities, or vibrotactile push buttons, things like that. Have you seen any of that used in conjunction with the rectangular rapid flashing beacon system? And if so, what sort of treatments? What is that like? I mean, are they similar treatments to APS, or are there different options there?
It's different than the APS push buttons, because the APS push buttons are actually to change the signal, but you can use some of the features from the APS push buttons, like for example a locator tone for someone who is vision impaired, and it actually helps others in the audience or others that are walking by, just to let them know that there is a push button by just calling the attention to it. You can have an audible message, or just when the flasher is on, or another kind of a message. One of the devices I've seen that actually calls out to a pedestrian if they detects someone nearby, and it says push button to activate flasher, vehicles may not stop. So you want to make sure that they know that it's different than a walk interval. So it's not something that's calling the walk interval or calling a walk, but it's calling a warning beacon, but that's still is just a warning beacon.
Yeah. Okay. We got a lot of questions, Mike, about using a rapid flashing beacon at trail crossings, specifically primarily at locations where it's mainly bicyclists that are crossing. Do you have thoughts about using the rapid flashing beacon at a trail crossing where bicyclists are the predominant users?
Yeah, that's the last case study I did was a trail crossing where the 80% of the users were bicyclists. And one of the things that they noted in the study, if you go read the study that was done at that particular trail crossing, is bicyclists tended less to use it, but I think a lot of that had to do is if they thought they could get across the street, they would just ride across the street. You're going to want to make sure that you have convenient push button actuation, or if you have automated detection at that location, that's going to be much more effective than a push button for a bicycle trail crossing. But anything that you have like a detection, that's not something else that has to be checked every once in a while to make sure that that's working properly, and there's going to be a lot more costs associated with an automated detection, either video, microwave, or some other type of device for automated detection. But that would be the biggest concern, is making sure that there is a convenient spot for the bicyclists to stop, and that they know they have to stop it and push the button to activate the flasher.
Okay. And on along the same lines, I guess, if there are particularly long crossings and you have a median and a center-mounted or median-mounted system, do you have another push button on the center mount, and that you can extend to extend the time of the flashing, or how do you go about handling that?
Yeah, I would not do it at all of them, but I could see at wide crossings where that people may only make it half the way, and then the flashing pattern would cease, that you would have an additional push button in the median. So I can see doing that at locations, and I am not sure. I'd have to go check back and see if the Phoenix locations where they're putting them in arterial streets with a raised island, and obviously it has to have a raised island there, that if they may be putting push buttons in the median as well. I know if you have a two-stage signal or a two-stage pedestrian hybrid beacon, that you in many cases would have to have a you would have to have a push button in the median. It's not a bad idea if you have a sizable median and a long crossing, so that if people are trapped there before when the pattern ceases, that they can call it back up again.
Yeah, several cities just chatted in and said that they do have split systems for divided streets. So okay. they do something similar to what you're talking about.
And in my travels across the country, I've been seeing more and more of these applications. And I wanted to start out with saying this is a new type of flasher, but I think a lot of jurisdictions already have experience using them at either individual locations or like the place where the rectangular rapid flash beacon was born in St. Petersburg, where they've got over 100 in place. So there's a lot out there, and then you can see them across the country. And a lot of people have found the benefit of these devices and are using them.
Yeah, absolutely. Okay. See, I had another question queued up already for you, Mike. This gets back to something what you were saying about the continuous flashing versus the pedestrian activated, but along a corridor, using a lot of these systems, have you ever seen a situation in which there become so many rapid flashing beacons that this becomes another background signal that a driver becomes accustomed to and can tend to ignore, just like something that is activated continuously?
I haven't run across an application like that where there's a lot of them. I just seen them where they're here and there, and typically when they're put in, the agencies that put them in will put them at their crossings of highest concern. So I really haven't seen where they've got them lined up and down the street. And the closest one that I've seen that I know of was the one in Arlington. They were a half mile apart. And that's definitely, you couldn't even see one from the other. So I haven't run across that situation.
Yeah, Michael Frederick says that that they actually have better compliance on some corridors where they have multiple rapid flashing beacons on the corridor. So that's an interesting finding.
Good.
Yeah. So this sort of gets at a question about advanced warnings with these treatments. So if you have curves, things like that, are you thinking about advanced rapid flashing beacons, and at what point and what distances are you thinking about putting those in ahead of intersection or ahead of the crosswalks?
Yeah, it really depends upon the speed. The higher the speed that you're more likely going to be putting them in and ahead of the crosswalk. And the biggest issue is that you need to make sure that there is an interconnect between them, and that may require the hard wiring, and that may require I don't know if the radio control. I was originally told that they want to try to get them the ones at the crossings close together for the radio operation to work. So if you put them in advance, you may have to hardwire them in so that they operate in unison. And maybe someone else out there has some more experience with an application like that.
Okay. I got an interesting note from Lewis Haywood in New Orleans. He told me that they are opening an urban multi-use trail tomorrow that has 20 rectangular rapid flashing beacons at 5 major roadway crossings, and that includes one with a 6-lane divided street in total. So he said that people have been using the system already, even though it hasn't officially opened yet, and they're already seeing some improvements in yielding. So that's a promising result, a pretty significant project, and that's again a trail location. So you've probably got a lot of variety of users, not just pedestrians, but bicyclists as well. So very interesting. Some questions here, Mike, about locations, multi-lane locations with rapid flashing beacons, where people are still having trouble with a multiple threat, not necessarily a multiple threat crash, but a multiple threat conflict. across those multiple lanes, vehicles stopping fairly close to the crosswalk. Can you make any recommendations about supplemental treatments at these sites where they might alleviate that problem?
And maybe either Michael Frederick can come up with some suggestions, but I know that the advanced stop or yield line, depending on if your state is a stop for pedestrian state or yield to pedestrians, and with the sign mounted at the side of the road, if you have to put a yield line in, a yield here for pedestrians, putting it at least 30 feet back, and the manual allows it at an uncontrolled location to up to 50 foot back to get the drivers to stop further back. There's going to be an element of enforcement that's going to be involved. You can't expect these things to plop them in and always work all the time for all applications. So those are some things, and maybe more in the way of pavement markings to other pavement markings, advanced ped crossing stencils to make the crossing stand out. And anything in the past, when we were trying to do a mid-block crossing, anytime you can make a mid-block look more like an intersection, the drivers tend to be able to recognize it that's a stopping location, and will have a better tendency to yield. So those are some of the things that I could think of. Possibly bigger signs mounted in it, maybe an application where you'd want to investigate an overhead sign.
Michael Frederick mentioned also that they use the solid lane lines in advance of the right in advance of the crosswalks to prevent passing or to deter passing right at the crosswalk location. So that's another good one.
Yeah, that was a standard practice. We were doing that here since I think the late 80s. Anytime we had a multi-lane road, to convert the lane lines into a solid wider line to discourage passing on the approach, so that there's not lane changing. Typically what happens is when one motorist starts slowing down the roadway, the person behind them who may be screened, well, the tendency is to change lanes and get around that slowpoke that's in front of them, only to find out that there's a pedestrian or someone crossing the street. State laws in virtually every state says that you have to, you're not allowed to pass a vehicle stopped for a pedestrian at a marked or unmarked crosswalk, and that is a big issue.
Mike, in terms of public education, you know, we all, I think there's a range of pedestrian treatments and different designs that, you know, each one of them may require a certain level of a sort of a learning curve before drivers and pedestrians both become accustomed. Do you see the rapid flashing beacon as something that requires a good deal of public outreach and education to sort of bring people up to speed on what it's intended to do? Or,
I would see not.
Yeah.
I see it's more of an intuitive device than something that requires a lot of education. I think more in the way of general safety education. If anything, the idea of using the push button and making sure that drivers in all lanes stopping, crossing one lane at a time, you can have that same education for any uncontrolled crosswalk, making sure that drivers in all lanes stop. So just the general pedestrian safety education. I know that when we installed a crossing device at a school or a senior citizen home, we would always go in and talk to the school officials. In some cases, have them even make, if it's a school, make a video for the rest of their students as a part of the learning process and the education process. Have the students help educate the other students of these devices. And but the big thing is making sure that they stop, push the button to activate the device, and then cross one lane at a time.
That's great. One other question that came in, an interesting question. I've not thought of it in this way exactly, but you talked about a lot of conditions where a rapid flashing beacon would be appropriate, or conditions where you'd like to see one put in. Are there anything you look for at a particular site that would deter you from putting in a rapid flashing beacon at a particular location? Maybe, for example, proximity to a driveway, or something like that. Can you talk about any other features of an intersect or a crosswalk that where you may think twice about putting a rapid flashing beacon in a particular location?
Yeah, I'd like to have a location where I can have a median or a median area. Obviously, you'd want to have the flasher in the median, so that may take out some driveway locations. But the predominant issue that I would be concerned about is the combination of speed and street width and possibly ADT. The wider the streets, the higher the speeds, the less likely a driver is going to stop for a pedestrian. And that's true at any type of device you have. But that's there are some things that in some cases we're building our streets too wide to make them not usable by many pedestrians. And the goal is to make our streets multimodal, make it so that it can be used by pedestrians and bicyclists, and not just by a way of getting vehicles from one end of the city to the other.
What about using these systems at transit stop locations, Mike? I mean, we're going to cover transit in a different webinar, but you know, when you're thinking about crossings, obviously you're going to need crossings at your bus stops and other transit locations. Have you seen these used quite a bit in conjunction with bus stops and other transit shelters, things like that?
I think they're an ideal application for these. If you're not going to be using something like a pedestrian hybrid beacon, I think that these would be good devices. We have the high crossing locations. You can't put them everywhere, but you'd have to look at what locations are the biggest need for it. And transit locations and bus stops, that your biggest users are the pedestrians. They need to be able to get from one side of the street to the other, or to the transit platform if it's in the middle of the street. So there are applications like that. I've seen them used at airports as well, in combination with things that sometimes with raised crosswalks. So there's a number of applications for these devices.
What about you mentioned earlier about maybe some ongoing research or some recent research on using rapid flashing beacons at roundabouts? Can you say anything more about that and maybe where folks can go for more information if they're interested?
Yeah, I know that and I don't know what federal highway research is being done, but they're looking at equivalent accommodation for multi-lane roundabouts. The people who are vision impaired have great difficulty distinguishing the traffic in a circulating roadway versus the approach and departure roadways. And they have a difficulty determining when it's their time to cross. So for single lane roundabouts, it's not that much of a problem for them, but when you have multiple lanes, that's when it becomes much more of a challenge. And I know that there's been research to look at what type of a device can be used as an equivalent accommodation so that you don't have to go for a traffic signal on the approach or departure lane for a roundabout. And there's been research that looked at a rectangular rapid flash beacon, but I don't know if I'm the best person to speak about that. I've not seen that particular research yet.
Okay. Yeah, and I'm hoping, Mike, we will be doing another webinar on roundabouts as part of this series. So hopefully we can pull some of that into that webinar as well. Some of the newer research on RRFBs at roundabouts. But yeah, I think that's a key issue is you know, finding some way to accommodate individuals with disabilities at roundabout crossings, and I think that maybe RRFB is the solution to that. So, okay, very good. One question, Mike, about just about public response to these. Have you received, or in your work with putting these in, what would you say are some of the most common arguments that you've heard against using rapid flashing beacons, or maybe not even arguments, but concerns people have? What are sort of the main arguments against using these sometimes?
I think some of the main arguments is just fear of the unknown, fear of not having any experience in the past. I think that people like Michael Frederick have no experience because they've had them in a number of places. But it's just the fear of and I'm talking about agency fear, of are these things going to be a maintenance headache, a maintenance burden? Are these things, and then there may also be a fear, am I putting them at the right spots? Do I have another place that's a higher need? And agencies should take a stock of all the challenging crossing locations they have, and I think the courts will protect you if you identified locations that are the highest need ones for these types of crossing devices. However, there may be some other locations that you may get a grant, a Safe Routes to School grant, for example, at a location that can be justified for applying it at one location but not at another similar location because you did not get a grant to cover that other location. I think, though, that the places who have installed them, I know, have been very pleased with the driver response. It's not 100%, but it's much, much better than the standard flasher that's been used.
Mike, you mentioned schools. You actually predicted my next question. You did a lot of work in Phoenix with the schools, Safe Routes to School programs, things like that. Have you, in locations where you've had rapid flashing beacons put in at schools or near schools, where there are crossing guards, do you have the crossing guards utilize the push button when they're having children cross? Do they use those systems the same way, or do they kind of rely on their standard methods and let the rapid flashing beacons rest blank? Can you say anything about those processes?
Our second application was the one at an elementary school where we have what's called a 15 zone. These are the portable signs that were put in the street, and the rectangular rapid flash beacon supplemented the crossing guard and the signs that were put in the street across a pretty wide roadway. And we just met with the crossing guards beforehand and told them that before you go out in the street to push it, let it lay dark in between your crossings, and then when you need to have it activated, go ahead and push it at that time. So it's not always flashing, but it's flashing at a time when you're going to be walking into the street. And of course, in conjunction with that, we also talked to the guards about looking for natural gaps so that you're not causing someone to come to an abrupt stop. But these devices have very good application at school crossing locations.
Okay. Mike, along the same line, get back into the previous question I asked you about arguments against these. Some people, I guess, have written in and said, that it seems to create maybe a false sense of security for pedestrians to put these at a certain location once pressed. And now, can you say anything about that and how you maybe respond?
And again, I'm hearing a little bit of other voices that are not coming from your phone or my phone. I don't know where they're coming from, but I do think that I understand the concern about the false sense of security, but I know that I think it's overstated in some cases, and the real need is to get people across the street. And if you don't feel this device is an appropriate device for your crossing, then the thing is not to say that we can't put anything out there. You have to look at what other devices or combination of devices should be placed at a location, and it may be done in conjunction with a raised median, and maybe done with some other traffic calming, narrowing the lanes on the approach to this location. So the overall goal is to serve the pedestrians and get pedestrians across the street.
Very good. All right. Well, Mike, you've answered a ton of questions. Thank you so much for doing that. I think what we're going to go ahead and do is close out the discussion for today. I provided you all with an email address in the chat pod for Michael Frederick, who is another excellent resource. I would encourage you, if you do have questions for him, reach out to him. He's gotten into the business of providing a lot of technical assistance on this, and is always responding to emails. I'm sure people are contacting him about these issues. So please reach out to him. You can reach out to us at HSRC. The email address included in the follow-up emails and all the marketing information. Please feel free to reach out to us, and we will be glad to help respond to your questions and put you in touch with the right people and the right resources to get those answered. That's all the time today, though, that we'll have time for a discussion. I think we did get to a lot of the questions, but if we didn't, I do encourage you to reach out to us. I want to remind everybody on the line, once again, that you will be receiving an email later today with a link to the archive page for the webinar. So right now, we've already posted the PDF of the slides from today. I'd encourage you to go take a look at those. There were a lot of slides with links to specific resources that I'm sure everyone wasn't able to just write down in real time. So refer back to those slides. You can find the resources there. The email will also include instructions for how to download your certificate of attendance for the webinar. And be sure, please, if you are attending with a group of people and you registered for the webinar, you'll be getting that follow-up email. So please pass that information around to all of the other people in your group so that they can all access it and print their certificates of attendance. I also want to let everybody know that once you close out of the webinar today, a very brief survey will appear once it's ended. We would really appreciate your feedback and comments on today's presentation. I want to say thank you again to Mike Sinecki. Thank you to Michael Frederick for responding to some questions as well. And thanks to all of you for attending today's PBIC webinar. And I hope everybody has a great day. Thank you.